Go live. I think we are live now. Can someone check if the audio is there?
No.
Just a second. Refresh the YouTube.
Yes.
Yeah, so we are audible, right?
Yeah. Can you disable the caption?
How do I do that? Wait, disable captions here. Okay, we are audible. Yeah, 1 second. Okay. So hi everyone. Yeah. So here are the problems we can now see.
Yeah. It's
What is this? Okay. I'll add the problem on the Miro board.
Yeah, so if you can have an equilateral triangle, then you're done, right? So
yeah,
and in general, if you can find an odd cycle, then you're done.
yeah. Well, with length pi, right?
No, I'm talking about the second part. Yeah, if you can find an odd cycle of points inside the circle, all which are all like distance pi apart, then
Yeah. That is true for A part also, right?
yeah, I'm like talking in general, just in case it helps for part B.
Yeah.
You can delete the, like, I mean, you can divide by pi.
Yeah, dividing by pi.
No, but how do you get R by pi then?
That's not pi.
Oh, we
No,
can zoom in by pi. Okay, okay. Yeah, yeah. I see.
Yeah, and replace like AB equals pi with AB equals.
Yeah. What is 1 by 1.7?
No, I'm just saying it's like equilateral triangle. It's like
You can obviously get that, right? Like just take the point 60, 120, 180.
Yeah.
That should work. Wait, what happens when the distance is 1 by 2?
So this is into sign up.
Wait, doesn't just PHP and this finish?
Yeah, like obviously these things will have distance greater than 1 or something. Wait, actually no. Wait.
Yeah, just PHP on this.
Oh, PHP on what points?
These 3 points.
These 3
equal.
points, I don't think they are equilateral.
Like there'll be some equilateral triangle with side 1 inside this circle, right?
No, the unit equilateral triangle is inscribed in a circle of radius 1 over root 3.
Yeah, and we do PHP
So
on its
like,
vertices.
let's take a unit equilateral triangle. Two points should have the same color.
Yeah. Oh, right. Yes, yes, yes.
And
Yeah, wait. Is this angle 120 then, though?
Yeah.
Yeah.
Oh, right. I'm so
Yeah.
slow in this calculation. So, yeah, fine.
Yeah, that works.
But usually what if R is greater than?
Yeah, in that case, I think find an odd cycle other than an equilateral triangle. So
In the second one, I think it'll just be no. And
Yeah.
No, it shouldn't be no, because like pi by root 3 is greater than pi by 2, right?
that can't be true.
We want to find like some diametric points.
Yeah, diametric points. You can just follow those alternately, no?
Yeah. R is like half. R is greater than half, and we want the distance to be 1.
Just like one semicircle blue, the other
Okay.
semicircle red.
Okay. That is the equality case when r equals to pi by 2. For anything greater than that, you can always find an odd cycle.
Okay.
Like in r equals to pi by 2, the diametrically opposite are 1, right? But when
Yeah.
r is greater than pi by 2, it will be like, wait, why did you raise that circle?
I don't want it.
Yeah. So like, let's say these are the two diametrically opposite points. These are distance greater than 1. So like there will be some point here which has distance 1. And then you can probably continue this to get an odd cycle somehow.
yeah, but you can keep on continuing this, but how do you know that you'll reach the original point in a finite number of steps? Wait, actually.
You should, right? Because you are always going by an angle theta, like if you take, and then sigma theta should be divisible by 360 at some point.
Yeah, only if theta is like some
rational.
like it divides
Yeah,
pi,
yeah.
something like that.
Yeah,
this
so
should
that
work.
is-
I see. And
Yeah,
how
like-
do you know the cycle will be odd, not even, right?
Yeah, that I realize now.
Because in fact, it looks like an even cycle because you're alternating between the two sides.
Yeah, I see.
So, then they're like. So the circle has diameter greater than 1, and we want 2 points which are like distance 1 apart and the same
Yes.
color.
Yeah.
Yeah.
Okay.
Oh wait, I think we have to somehow use this stuff. Like, let's say this point, then it has 2 points which are at distance 1, right?
Yeah.
Yeah.
So like everything has 2 points somehow. So how do you finish this? No, let me see.
Mm-hmm.
Wait, what is the problem with an even cycle?
Because even cycle doesn't guarantee that the 2 points have to be of the same color.
Oh, okay. Yeah. I confused same with different somehow.
So what we are trying to do is prove that the graph where 2 points are connected if they have unit distance is not bipartite.
Yeah.
We can make it finite easily.
Okay, I have this idea that if you take a regular, say, pentagon and draw all its diagonals, they have the same length and they are all larger than the sides. let's say all of them are unit distance. Like, what's the smallest circle you can inscribe this pentagon in? But then instead of taking a pentagon, you generalize it to a regular 2n+1 gon, and you draw all the longest possible diagonals. And like, what's the circle you can inscribe them in?
Since it's regular, the smallest circle will be like this only, right? The second circle.
Yeah, but if you take say a regular, like very large regular, this odd n-gon, then like you can, and say it's a 2n+1 gon, you connect this point with the one n units apart.
Yeah.
And you say that longest thing as unit distance, that longest diagonal, then I think that approaches the diameter very like, and the circle, the radius of the circle approaches 1.
Yeah.
Diameter, sorry.
Yeah, obviously, because if we take n to be large, this will be approximately the diameter, right? It goes close to the diameter. So you can take as large as you want, but we cannot just reach pi/2. Yeah, so we are done. Right?
Yeah.
Yeah, because this will be like, suppose this is the center, it's here, then here, and here. It keeps on going. You can take it as close as you want, but not the center. So yeah.
Something like, say this.
Where are you going?
Yeah. Yeah, that should work.
Yeah, that works. Like, fine, if you want, we can probably show that the distance keeps on decreasing as we increase n, but that's just calculations, right? We can probably skip on that. We can use,
I
like,
think you can just use the sine law, like sine of this decreases and
even sine, or we can even use roots of unity probably. Yeah, that would work.
That just works.
Okay, it was not that easy, I guess.
Yeah,
I mean, not that hard, but fine. It was a nice one.
Odd cycle, so I mean bipartite, so odd cycle. This is not really tricky.
Okay, second problem. It will be really funny if you finish before Kanav comes. Alice has an into.
X is k cube. X on 0.45. 3, 6.
I think we just have to show that X does not cycle, because if it cycles,
yeah, that's what I was thinking. It cycles.
Oh wait, is this true that eventually 2x+1 never gives a cube?
Yeah, if you keep on.
Like, what is a cube mod? -101, right?
Mod 8, right?
Oh, mod 7.
Yeah, mod 7 it's 0 plus -1. Yeah.
Okay, so if X is 2 mod 7 or 4 mod 7 or 5 mod 7, it will never be a cube eventually.
2, 5, 4. Okay, fine. Yeah.
Yeah, because they form a cycle among themselves, right?
Mhm.
So we just have to show eventually it will be 2, 4, or 5.
But see, this 2x plus 1 is bijective modulus 7. So nothing else reaches 2, 5, and 4. So it's
Yeah.
either 0, 1, 3, 7 is a cycle, 2, 5, 4 is a cycle. So these things never reach 2, 5, 4.
Yeah, but like, okay, let's say if it is in the cycle 1, 3, 7 in the beginning, then
Yeah.
we also do cube, right? So it's possible
Ah,
that after doing the cube, it comes to 2, 5, 4. That's what
yeah.
I'm saying.
Oh, right. Yes, that's true.
You're controlling the modulus of the cube, right?
Good question.
What are the cubes mod 8? 8 seems
Mod
to be-
7, mod 7.
Yeah, mod 8. What are they?
Mod 8, it's
Why are you
like,
taking mod 8?
it's not, it's like,
Because we have 2.
so mod 8 is like 1, 3, 5, 7, and 0.
Oh, okay. No reason.
Yeah.
Also
So
see
how many-
mod, yeah.
Go on.
You can also see mod 9 because mod 9 is 0 and plus minus 1 again.
Yeah.
And in mod 9, you have this 3 divides. If 3 divides it, it's 0.
Yeah. So in mod 9, the cycle is 2, 5. Okay, 2, 5, 2, and 3, 7. What is 15? 6. 4. Yeah, in mod 9, it should not be 0, 1, or minus 1. Okay, mod 9 seems more promising, I guess.
Yeah, so 0, 1, minus 1. 2x plus 1. Get rid of it.
Oh, we can probably do case bash. Like, okay, not that bad case bash, but like, let's say at the point when x is a cube, it's divisible by 9. So it's like 27k cube. So it goes to 3k. Now, if k is not 0 mod 9, this will obviously die, right? It's like either 3 or 6, in which case it will never be a cube again. If it's like 1 mod 9,
Uh-huh.
so it should be like 9k plus 1 cube something. Right?
So 3, 7, 6 is 3.
No, it can be 9k plus 1 cube or 9k plus 4 cube. Or what is 7 cube? 343, right? Or 9k plus 7 cube. Right? If it's 1 mod 9, the cube.
Yeah.
And in the next step, this will be 9k plus 1, 4, or 7. So the only issue is when it's 9k plus 1 again. Because in these cases, it dies out.
But this can happen like,
But how do we show this eventually is not possible? So wait, how many people are in the stream? I'm curious. Has anyone stream opened? Oh, 9 people.
eventually you will get something which is like not a cube. 9 plus 9k plus 1 cube, then You will hit some 9k plus 1 which is not cube.
Oh, wait, speak again.
If you have 9k plus 1 cube at the start, then you will hit some 9k plus 1 which is not a cube.
Yeah, but that's fine. But then we can keep on going, and then eventually it will be a cube again, right? Because it's 1 mod 9, so it cycles between 1 and
Oh yeah.
I didn't get why is 3k an issue?
Yeah, it's not an issue, I think, because k can be divisible by 9.
Yeah.
Like if 2x plus 1 is 27k cube, then k can still
right.
be.
Yeah, again, it's the same problem.
Yeah.
Like only 2 and 5 are disallowed, right? Everything else is allowed.
Oh,
Because after 4 you have 0.
yes.
After symmetric that.
Like even 8 is in a cycle of its own.
Yes. What genius calculations I have. Okay, no, then mod 7 looks better, no?
Yeah.
I think there should be another way. We're probably like doing something wrong.
Okay, what if we can only show that there's a cycle less than 10 to the 100, but we can't show in general there's not a cycle.
That would be insane.
That is unlikely. Like, no, you have to show it exceeds 10 to the power 100. Right? So if you show that there's a cycle, there's no cycle less than 10 to the power 100. That is
Yeah.
Oh, I see your point. But no, like 10 to the 100 just seems very random. Come on.
Yeah.
Oh, for a moment I got confused that this looks like Goldbach's conjecture. Why is this so long? Hi, Kanav. Wait. Yeah, he's there. Hi, Kanav. Has to click it already. Okay. Kanav, I've shared the Miro link in the group DM. You can find it from there. Also, the problems are also in the group DM. We are doing problem 2 right now. And you are on mute. Okay. Oh, okay, that is fine. You can say your ideas. You just write those if you have. Well, it's 2x plus 1.
Yeah,
Right. Oh, that is why I was doing calculation error in some areas. Okay. This is a bad idea.
I don't even think this fact is useful, but if P congruent to 2 mod 3 divides x plus 1, then it will always divide x plus 1. Like if it divides a number plus 1, it will always divide a number plus 1, I think.
Can you repeat that?
Because like 2x plus 1 preserves modulo x plus 1, modulo p, and cube root also preserves modulo p. At least, yeah.
Oh, P divides x plus 1, then P divides x plus 1 ways. Yeah. P divides x cube plus 1.
Can you repeat once?
If prime congruent to 2 mod 3 divides a number plus 1, it will always divide a number plus 1. because cube root is bijective mod P.
Mhm.
So you are saying like, okay, yeah. And what is x plus 1 here? Like the x is the
Our
number in
number
the
plus 1.
sequence.
Yeah, whatever our number is at. But yeah.
In the sequence, right?
Yeah.
Yeah, okay.
So,
Why did they specify n greater than 1? That feels unusual.
because one cycles to itself. One goes
Does
through.
though.
Because one is a cube.
Oh, okay, okay.
Okay. This one. This- this one. Interesting.
I remember someone saying that they had solved P2. I wonder how.
Okay, we can also look at the V2 of x plus 1. Then,
Yeah, that's what I was trying now.
yeah, so if like 2 to the n divides kq plus 1, then wait, k squared plus k plus 1.
Then 2 to the n must divide k plus 1.
Yeah, so the V2 never decreases.
Wait, what? Go on. Can you say that?
V2 of
Yes, it always
number plus 1 never decreases.
Right. V2 of number plus 1 never decreases. So you're saying if V2 of x plus 1 you have.
If x cube plus 1 goes to x plus 1, then x squared plus x plus what's it? Yeah, whatever, that's odd. So both of these are the same V2.
Yeah.
And this
What
operation
if x
only,
is even? What if x is okay? Yeah. No, what if x is odd?
It's like x squared plus x plus 1, which is always odd.
wait,
Oh, yes.
if it's 2x plus 1, should we instead look at x minus 1?
Well, aren't we
Because
done?
the V2 increases, otherwise.
Every time
No,
it takes a cube root, it increases, right? Yeah, every time you take a cube root, it strictly increases.
No, it does not increase, it stays same, no?
It's same. Yeah,
It stays
but like it's divided by x square minus x plus 1, which is always odd. So it stays the same.
Oh,
But x.
but every time
plus
we go
one-
up one, it strictly increases.
yeah, x plus 1 goes to 2x plus 2. That's what I was saying. Yeah. So the V2 increases, right?
Yeah, doesn't this finish? Yeah.
Why does it
So the
increase? Why I'm
V2
so slow?
Uh-huh.
Wait. If x is odd, then this is 2. Wait, like if x is odd, the V2 here is what?
X plus V2 of x plus
Oh,
1.
V2 of x plus 1 we are checking. Okay, yes.
Yeah.
Yeah, fine. It increases.
And here we are looking at V2 of x plus 2, 2x plus 2.
Yeah.
Yeah, so it increases a lot more times, then it stays constant. So it will eventually pass into the behind.
Yeah.
Okay, yeah, that is fine. I'll just quickly explain the proof once again because yeah, so let's say V2 of x plus 1 is non-decreasing. And when x plus 1 goes to 2x plus 1, it increases. And when x, when
Like x goes to 2x plus 1 and x plus 1 goes to 2x plus 2.
yeah, so x plus 1 goes to 2x plus 2. In this case, V2 is increasing, and when x goes to cube root x, the V2 remains same. But x goes to 2x plus 1 occurs a lot more times than cube root of x occurs. So like it increases a lot more times. Hence, it will be as large as you want eventually.
Yeah, that's it.
Okay, we can do P4, P5 right now. And we can look at 3 and 6 later. That
Let's just try 3.
you want to do 3?
No, let's just see what it says, like several.
Or see the problems you mean?
Okay, fine. Let's try 4 or 5.
Yeah, like 4 looks nicer. It's an F field.
Yeah, that's.
Yeah, how is P1 Geo?
Well, like.
It's not Geo still. Okay.
R to R. Just which G of x?
Okay, it probably looks true intuitively, the problem.
Well, we have that f of g of x is equal to f of g of 0 plus x. I feel like.
Huh?
I'm just x equals 0 and then y equals 0 and then
Yeah.
equate. This kind of shows a periodicity kind of.
Yeah. But that is it's only product is that, what do you say? No. Like what if x is, let's say, bijective? Okay, if x is injective, then g of x equals to g of 0 plus c. It's a
Yeah, I
linear
guess it
function.
doesn't really have. Yeah, it's
Yeah, but
linear.
if can f be not injective, then you can plug. Then g has to be periodic, right? If f is not injective. Because say f of g of x plus y1 is equal to f of g of x plus y2, then that implies x plus y1 is, wait, sorry.
So if G is if G is not injective, we get that G is periodic.
Yeah.
Wait, if g is not injective or f?
Wait.
G. So say G of x1 is G of x2. Then you do P of x1 comma y and P of x2 comma y. The left hand side is same. So the right hand side is G of x1 plus y. is g of x2 plus y. So that's g is periodic.
Okay, so G is injective.
Yeah, so basically g is injective.
Now, if G were surjective, then F would be the identity because f of g of x is g of x. Right.
Yeah. Which is injective.
But the image of F is the image of G.
Yes.
So does,
What does it mean? What? How?
like by varying Y, the image of F is the image of G.
Oh, right. Okay.
The image of G is a subset of the image of F, right?
Right.
Or actually, I guess it's probably
No, but you can also like fix the
very Y.
Yeah, that thing.
Yeah. Oh, so we are not assuming G to be periodic, right? Like if it's not periodic, so we have it G injective, and now we're trying to show it's surjective, right?
No, we are not trying to show it's because I think showing
We have assumed that g is injective.
G is injective, then if G is not injective, then it's periodic.
If it is G is injective, then F should also be injective, right?
Yeah. So from this
Yeah.
thing, f gx equals to gx.
Yeah.
No, like so then just swap X and Y in the first.
Right.
Yeah.
Yeah.
You get
Well, I
G
mean,
is linear.
from here also it comes, no? Oh no, it doesn't. It
Yeah.
No, it doesn't.
Oh, you're right.
Yeah.
You have
G
to
of
use
x
the
plus y is G of y plus x. So G is linear. Yeah.
Wait, how is f is injective from here?
No,
If
F is
F
not
of-
injective, but
So F is right. If F of A is F of B, choose Y to be A minus G of X, fix an X, and Y to be B minus G of X. So you would have a
Y to be a minus g of x.
fix an X is 0.
Sure. So f is
And you get F of A is equal to G of whatever stuff.
yeah. So how is this injective?
And the other thing is F of A is F of B, then you get that F of B is equal to G of B minus G of C there. So you have injected. Because G is injected.
Wait, can you still say the finish? I'm still confused. You said it too fast.
Okay. Consider X0 and Y A
Yeah,
minus G.
You
0,
get this.
and consider X0 and Y B minus G of 0. Where F of A is F of B. If F of A is F of B. B minus G of 0, same thing, just replace A and B,
This, right?
B.
Oh. You get this, right?
Why are you putting an F? It's just G, no? Like F of A is equal, F of B is equal to G of B minus G of 0. Should be an F on the right side, no?
On the right side? Oh yeah, FGX. Okay, yeah. Yeah, so you get this. And A equals to B,
Yes, yes.
right?
Then you get A equal to B, so F is injected.
Yeah, okay. Oh what? Yeah, fine.
Yeah, F is in G and F both are injective.
And then G linear.
And G linear?
Yeah,
Okay,
from
yes.
that equation.
Which one? This?
F of G of x plus y equals F of G of y plus x.
Oh, if G is linear, we are done
Yeah.
from this equation.
Yeah, because then
Yeah.
G is
Subjective.
surjective.
AJ.
Yeah.
Yeah, okay. So, but why is this linear?
But if
Oh, it's linear by the boxed, the lowest boxed.
This thing, right? You're saying.
Yeah, this one.
But why? Wait. What?
Not that one.
No, but this also implies, right? G of x plus y is g of y plus x by the injectivity of f.
Oh, yes.
Oh,
Oh yeah.
Yeah. Okay. Yeah. So,
Yes.
wait, this is G is linear.
Yeah, g
Oh,
is
and
linear.
then
Yeah, from here.
Yeah, substitute g of x equals x plus c.
okay, and then you get F is linear. Yeah. Okay.
If G is, yeah.
I see.
Hmm.
This is a decent problem.
Yeah.
Sequences. Following.
Let's see. K-pop. Who is the proposer? RG?
the K-pop.
So Tanne. Oh,
Oh, how many k-pops?
yeah.
Distinct elements.
N is equal to the number of distinct elements. Okay, this is interesting. Very interesting. In fact.
So the
Yeah.
sequence is infinite, right?
Yeah.
And 1111 is a k-pop sequence.
Yes.
So
P for
is there anything else?
1, 2, 3, 4, 5, 6. No, that does not.
No.
Is that the only K-pop sequence? Yeah, the only one pop sequence is 1111, right?
The only one pop sequence is 111.
No, actually no. It's possible to have something
Like 2, yeah, the next one has to be then something like
this also works. This is a one pop sequence.
yeah, this is one pop.
Yeah, right? Because like take 4,
Yeah,
let's
yeah.
say the 4 distant elements. Yeah. Okay, there is no other one pop sequence. So the only two, there are two one pop sequences, 1 1 1 1 1
Yeah,
or 2 3 4 5 6.
but what if the second? Okay, it can't be 2. Yeah.
Yeah, it can't be
Oh.
greater than 2, right?
Oh, and the sequence is increasing, like non-decreasing.
And an plus 1 minus an is at most 1.
Wait,
Yep.
what is
Yeah.
1? An?
Yeah, that's one.
No, but what is at most 1? Wait.
Like n plus 1 minus an is at most is between 0 and 1, is 1 of 0 and 1.
Yeah.
Yeah. And the first element can be at max k.
Yeah.
Plus 1. K plus 1.
K plus
This
1.
seems,
Yeah,
seems
k
simple.
plus 1, k plus 2, dash, dash, dot, 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 dot is a k-pop sequence.
Why should the first be at least K plus 1?
At most.
At most, sorry.
Because
Why?
like if
Because only k plus 1.
elements in the set, right?
Yeah.
Yeah. Okay.
Okay, yeah. What are the possible 2 pop sequences? One is this 3 4 5 6, right?
Did they ask you to count the number of sequences?
Yeah, different.
Yeah.
How many K-pop?
Okay,
They
that
do
means
not
there are
ask-
only finitely many.
Yes.
Yeah.
And if there's a 0, then that means the element is the same as the last one, right?
Yeah. No. Yeah, like the new element which is added is equal to sum out of the earlier ones.
So an plus 1 minus an must be an plus k plus 1 minus an plus 2.
Are you saying this? An plus 1 minus an equals to an plus 2.
Right, yeah.
Why?
Because an plus 1 is only one greater if an plus k plus 1 is like a new number. So if it's a new number, it must be 1 greater than the previous number.
Yeah.
So the sequence is determined by the first k terms.
K plus 1 terms.
Yeah, k plus 1 terms. Yeah, so there are only a finitely many sequences. That makes sense.
Yeah. There can be like k plus 1 to the power k plus 1 sequences at max. That is a very big bound.
So let's try.
I think you could also just have like 3, 3, 4, 5. Why wouldn't this work?
For 2 pop, because
Yeah.
This might be.
6, 7. I think any correction on the first k should be fine.
Yeah.
No, not any connection, because like
No.
let's say 2, 2 in the 1 pop sequence. 2, 2 does not work, right?
Up to the first k, right? Here there's like more than k.
Oh yeah, okay. Up to first k plus 1 terms we're taking, no? For the first k. K plus 1, I guess. Actually, no, k, right? Because this 4 is determined by 3, 3.
Yeah.
Oh, this does not work, Sidharth.
Why doesn't it?
The first 3 elements should have 3 distinct numbers, right?
Yeah.
Oh.
Yeah, so the only thing starting with 3 is this. What is the only thing starting with 2?
2, 2, 3 probably. Yeah. Just subtract 1.
Wait, this is 2.
This should also work, right? 2, 3,
Yeah.
3, 4, 5, 6. Or not? No, 2, 3, 3.
No, this doesn't work because
No, here
I
it should
guess
be a
2,
4.
2, 3.
3. Oh, this works. 2, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Right? Because take any element, let's say you take the 5, or there are 3 numbers distinct previous, 4th is here and 5th is here. You take this 5, same number plus 1. So yeah, this works. Right?
Yeah.
Yeah.
And then here also it would be the same. I guess. No, 2, 2, 3, 4, 5 doesn't work. Because look at 3.
Yeah.
Oh, yes.
So I think it should be the same idea. 2, 2, 3, 3, 4.
4, 5, 5.
Yeah.
Okay, now we have to check the sequences starting with 1.
That is just 1.
Yeah, it's just 1, 1, 1, right? Oh, I think the number of K-pop sequences should be 2K. It's a guess. Malay left. Right? Oh, it's mine. Oh, no, you were there. Okay,
Is it 2 to the power k?
oh, yeah, that is also possible. Does
I
anyone want to
think we
form
have
3?
the general idea of what the K-pop sequence will look like.
Yeah. I feel
It's
like
not counted.
if we take any sequence, no, that's not. Sidharth, do you want to form 3 pop sequences? Do you want to form 3 pop sequences?
Yeah, I was drawing, like I was writing them. You have like 1, 1, 1, 1, then 2, 3, 3, 4, 4, 5, 5. Then I think 2, 2, 3, 3, 4, 4, 5, and 2, 2, 2 will also work. like all offsets.
Oh, hi, Sunana. Wait, are you sure no other works?
No, because you'll have also higher ones, right? 3 will also work, and I think 4 will also work.
No,
Just
for
for-
2, starting with 2.
Oh, starting with 2, I think so. Yes, because nothing else will work.
Oh, makes sense. Oh, so like, see, if we say 2, like this is position number 2, position 3, position 4. So here only one thing increases. Let's just pick the step at which it increases, right?
Yeah.
Like, let's say it increases at this step. So it's 3. Then everything is fixed. Or if it's at this, yeah. So basically, how many are there? 1, 2, and 3, right? Starting with 2, there are 3 things.
Yeah.
So now let's take when they start with 3. You have the same idea, right? They can increase at
2 stops.
3 stops. But okay, yeah, they can increase at oh wait. Yeah, they have to increase at 2 stops.
Yeah.
Which is quite hard.
No, why?
Is
Like
not
just
hard?
Uh,
take 3 choose 2, right?
X1 will number of 3, X2 will X1 4, 3 number of 5s, X1 plus X2 plus X3 is 4. Order is fixed. Count number is simple.
उसका आवाज कट रहा है ना?
I'll type.
Sorry, I got disconnected.
Oh, someone left. I was wondering it was Malay. I did not realize.
No, it was me.
Yeah. Now I realized when you joined again. Let's say that does this work as a K-pop sequence? 3, 3, 4, 5. Let's say.
Then how are you continuing?
Yeah, that's what I'm asking you. The next element should be 6, right? Because of the 4.
Oh, you have a break, one more spot. Wait, no, it should not be 6 because of the 3 before.
It should be 5.
It has to be a 5. And then
The
it has to
next-
be a 6.
And then due to
It has to be a 7. I guess it just gets determined. Like, it's fine. I think any starting will work. Yeah, how can there be a contradiction?
Array, we just got a contradiction of previous. Kanav. X1 number of 3, X2
No, but that
number
didn't
of
adhere
4.
to like the principle, no? Like we
Wait,
started
what
too high.
X1 number of 3, X2 number of 4, X1 plus X2 plus X3 equals to 4. Is this what 3-pop sequences, Kanav?
Yes, like general also same idea works.
How do you get there?
If
Wait,
you
like
start with
no, the starting can be with 2 also, right?
yeah, you can start with any number.
Wait, so what does it mean by X1 number of 3?
Array, like okay, this is for 3-pop sequence when they start from 3.
Let's start from 3.
No, like any terms is consecutively 1. And each term has to be at least 1. Yes, each xi also has to be at least 1. I guess my voice is breaking.
No, your voice is fine, but I couldn't understand what you mean.
Like what I'm saying is that this sequence corresponds to 2 3s, 1 4, and 2 5s, right? And then
Right.
your order is fixed. And first k plus 1 terms, or in this case 4 terms, fix the remaining sequence. Okay, so what I mean is x1 has a number of 3s, like the way you do in those IOQM counting problems.
Oh wait, is X1 is the number of 3s in the starting? So like
In the
And
first k
x2
plus 1 terms. In the first k plus 1 terms.
yeah.
Like
So it's
this
like-
is a special case for 3. You can do
Yeah.
it for n. And each
Right.
xi has to be at least 1. In this case.
Yes.
In any case.
Oh, so it's like then these are the thing which you wrote in chat. This is for the 3 pop sequences which start
Yes.
with 3, right?
Yes. Yes.
So it's like 3, 4, 5, 5 is possible thing. 3, 4, 4, 5 is possible. And you can just form any sequence with these things, right?
Yes, it should be valid. I didn't check that.
Yeah, it should be like with this thing you said. Like, where is
The
it?
distance. No.
Yeah, xn plus k plus 1 minus xn plus k equals to x2 minus x1. Whatever. Where was it? Yeah, this thing, right? An plus 1 minus an equals to an plus k plus 1 minus
Yeah.
an.
I didn't check if this is sufficient. That's
It should be, right?
It looks sufficient. Like what any starting point, you should be able to continue.
Yes, the number of solutions should be just these.
Oh, wait, there is an issue. Like, oh, everything is greater than equals to 1.
Yes, yes. That's what
Yeah, this should work. Yeah, this works. So, what is the number?
I don't know. I didn't
It'll be
count
this.
that.
Yeah, I'll just count
Right.
that. x1 plus x2 plus x3. Wait, how many terms are there? Plus x.
P3. In this case, 3.
No, in general it's like K, right? For K-pop.
No, like not necessarily 3, because like if we start with 2, 2, 3, 4, 5 also works, right?
If you start, just consider first k plus 1 term. Those would start.
Yeah, that's
Start
what I'm
with-
saying.
Start with 2. Then for 3 pop sequences, 2, 2, 3 works.
2, 2, 3. But then,
Ah.
but then if you notice that x4 is 0 here, right?
Yeah, no, everything ka xi different. Then change. Like, count from fixed starting points. No, wait, what? 1 second.
Yeah, the answer is just 2 to the k. Yeah.
Wait. How does it do?
That's 0.
Oh, right. Wait, yeah, and wait, is every sequence possible that way? Like, what if you have 3, 3, 3, 3? This does not work, right? Like-
But the number of, like, you didn't satisfy the number of ups, like the number of increases.
Matlab?
There have to be 2 increases. Like in the first 4 steps, there have to be 2 increases. Otherwise, like the first 3 isn't satisfied, right? If you just put 3, 3, 3, 3.
Yeah. Oh shit. Stylus
Cool.
broke, I guess. Oh, it's still fine. Yeah, each xi at least 1. But what if you take 2 in the beginning? Then it's
It
like,
change. Like, just define x1 to be number of 2s, x2 to be number of 3s.
Just like this, we have to choose, like if it starts with j, then we need to put j minus 1 increases in k spots.
oh,
And we just sum over
yes.
that.
Okay, fine. Yeah,
Yeah, but Sidharth did.
yeah, I see. Yeah, okay. I was confused in this x1 and x, like till where it goes. Yeah, fine. Wait, Ananda,
But-
did you see it too?
I think it's very clear that any starting will finish.
Yeah,
Like any
so
starting.
because of this thing, right? So the inequality Kanav said, an
Yeah.
plus 1 minus an equals to n plus k plus 1.
Yeah, this one.
Yeah. Wait, so we are done, right? This was a nice problem. Actually, the problems are nice only, everyone. Or genius.
The basics next.
Justice for G or justice for Atul's problem. Okay. So we will completely ignore P3 and do P6. Who was the proposer for P3?
Wait, what was P3?
Kanav plus Anand.
P3 was the grid problem.
The grid.
Yeah. We'll do it then. Let's do P6.
Yes.
Isosceles triangle, coordinate bash for the win.
19 space.
I thought, how happy will you be if we bash this?
You think you can bash it?
Huh?
Have you seen the points PQR?
No, not yet.
AP.
What?
What?
How are these points even defined?
Okay. Oh, because it's 19.
Okay, right. So BP is the circumcenter CVN.
Bro, let me draw the figure. Let me draw the figure. Wait.
And okay, then Q is defined that way, and RP equals RQ. Okay, so it's like all the points.
Circumcenter CVN. Okay, okay. Let's see.
Uh-huh.
Oh, yeah.
APQ and CRP.
I think I can bash this.
You
Except
can.
until the circumcenter parts come in.
Mm, maybe.
APQ and CRP. Atul, why is this not symmetric at all? Like, couldn't it be BQR and CRP?
Oh, CQ is the altitude.
The point
because
of the problem was to be non-symmetric and non-config.
because like CQ. Wait, is it really the altitude? Because these two are congruent, right?
What two are congruent?
ABP and no, sorry, what was I saying? Okay, they're not actually.
So let's just label them.
Like if you reflect Q across the midpoint of AB, then sorry, that's not true. Yeah, it was.
How do you even involve this length? I'm pretty sure you can set up nicely, like the barycenter coordinates nicely for PQR. And then you can probably calculate this O1 and O2 using this thing.
Hmm.
Wait, what is the barycenter circumcenter for a general triangle?
Mm-hmm.
Okay.
You haven't even added the circles, bro.
Yeah, that did not seem nice what I added.
Okay. Okay. Okay, might as well add the third circle.
Sure.
Then BR is O1 or 2.
I'm guessing O1 O2 is parallel to their opinion, not anything. Oh, O1 O2, I was thinking.
O1 or 2 is parallel to?
BR. That is not true.
Okay.
There should be some sort of congruency or similarity though, right?
Okay. Oh, the midpoint of PQ lies on the medial line of like ABC, the A medial line because of AP equals BQ. Is it in fact the yeah.
How does that help?
I don't know. Adding the midpoint where it makes sense.
Oh, RO1 and midpoint are collinear, right? Both lie on the perpendicular bisector.
Yeah. So
We can find the angles in the triangle APQ with respect to O1 also, right?
with respect to O1. Yeah.
Like, yeah. But we cannot do so for triangle CPR because like we do not have angle CPR with us or like CRP. Or do we?
Yes.
Okay, I will leave now.
Oh yeah. Okay. Bye bye.
Bye. Also, let's add the circumcenter, like because it lies BP, the circumcenter because it lies on BP. Maybe you can.
Oh yeah, true. Oh wait, does it also lie on O1 or 2?
Yeah, that's what I was thinking as well.
Oh, that is
So O1, O2 is the perpendicular bisector of PR. Right.
no PR.
PR.
Is there any chance that R can be the midpoint of BC?
R can be the midpoint.
Okay, that's not. Because I was thinking that maybe O1 or 2 equals to RC also. Probably.
No, that's not possible.
Yeah.
You can take extreme cases. Oh, okay, that's not possible.
What would be the extreme case?
No. I forgot this angle condition.
Okay. Wait, why am I getting wrong angles? Oh shit.
Also, like if AP A dash Q is a parallelogram, then A dash is on BC.
AP, what is A dash?
Like A dash is the reflection of A in the midpoint of PQ.
Okay. AP A dash Q is a parallelogram.
Yeah, because
Yeah, that is true. Then
so yes, but we don't know what the point A dash is.
yeah. Also, can we somehow involve the Mikhail point in the configuration?
Yeah, Mikhail.
Okay, there are two things. If we have to involve the circle BQR, then we should involve the Mikhail point. But I
True.
guess BQR is just unnecessary because like it's not at all related, right? I don't see it being useful anywhere.
I don't see anything at all.
Yeah, that is true.
Can you move your cursor?
Yeah. Also, by the way, on the top right, on the left of the names, you can see an option. There is a party thing and a cursor thing. You can disable that. After that, you will not see anyone else's cursor. Look here, technically. Wait, how is O1 perpendicular bisector of PR? That's not true.
Oh, right. Yeah, that's not true. Sorry.
It's not a bar. No.
Yeah, that's not true.
O1R is the perpendicular bisector of PQ.
Yeah. Okay. I feel the finish should be somewhere like you have to find two congruent triangles
Exactly. Yeah,
involving
that's
BR
what I
and
was.
O1O2. Yeah.
Okay,
I feel one of the triangles. Okay, this is just a guess. One of the triangles should be O1RO2.
O1RO2. Yeah.
Don't answer that. This is also a guess only. Wait, what are the circles involved? APQ and APC, PRC, right?
Yeah.
Or it can be O1, PO2 also, because like P is the common point. Yeah. But what is the nice triangle involving BR? BRP or BRQ?
PRP.
Yeah, because you know the angle RBP.
The angle RB.
Oh, yeah. Yes.
Can we find any other angle?
Yeah, this RQ is RP conditions.
But where are the captions? Oh shit. How do we close the caption? Yeah, how do we turn off the caption? I do not know. There. Why does this feel like some charade problem this year?
Yes.
PR perpendicular to BC or like height P?
Malay?
To BC.
Yeah.
Then this is like your PRC and
Wait, is PR perpendicular to BC? Are you saying?
I'm asking, but wouldn't like, is there a chance?
Oh,
But that APR must be collinear.
what should we call in here?
Oh no, nothing.
Hmm.
Oh wait, we haven't used AP equals to AC yet, right?
AP equals AQ equals PC, right?
Yeah.
So
Like AB equals to AC, same thing.
yeah, so one thing you can do is like complete the parallelogram.
Which parallelogram?
Like complete the parallelogram for APQ, then that other point will lie on BC.
Okay. Wait, is that other point R?
I don't think so. Like
No,
it doesn't
look
look
so.
through in the diagram, and that would imply AP equals AQ if the other point were R.
Huh. Wait, I think Atul, you turned on the captions, right? Can you turn them off? Oh, you didn't. Ah, I don't know. Can't say.
Proposed as a P1.
Yeah.
Not
So we have, if we add O is the center of ABC, you have OP. Wait, APOQ is cyclic. Wait. Yeah, it is cyclic because if you add O is the center of ABC, then you would have OP is OQ by power of point of P and Q. Yeah, and OP bisects QAP, so O lies on QAP.
yeah. OP is OQ.
Yeah.
And
Oh, yes.
Yes.
so APOQ is cyclic.
Yeah.
So where
So the
oh, so
Mickel point.
this is point O, right? Yeah, so this is point O. No, it's not the Michele. O lies on BP.
Yeah, it would not be, might not be the
O
weekend.
lies on
No, there's
BP, right?
this thing
Ananda.
which is that if O is the Mickel point of like these PQR, then PQR must be similar to ABC, and ABC is isosceles, PRQ is also isosceles. So it might make sense. Anyway,
Oh, yeah. This diagram is not accurate.
yeah. I mean, if PRQ were similar
Like in
to
that case, the Michele should lie on BP.
Your voice is breaking.
is my voice breaking or is Pranav's?
Pranav's.
Oh, okay. Yeah. Okay, what? BR is O1, O2. Okay. Okay, he left. Are we? Oh, we are still streaming. Yes, that must, yeah, R must be like, O must be the middle point. Because like if you define R as
just a second, let me screen share again. Yeah, can you say it again, Ananda?
yeah, I was saying that O must be the middle point, and we must have PRQ is equal to BAC. Because say if you defined R dash is equal to BQO intersection BC is equal to CPO intersection BC, then R dash PQ must be isosceles.
Dash PQ.
We still have to show that it's 2 alpha, right?
No. What I'm saying is that O dash has to be the middle point of PQ, PQR, because if it were not, then suppose R dash is on BC, such
Okay.
that O is the middle point of PQR dash. Then R dash PQ must be isosceles by angle chasing or by whatever you want.
Yeah, I get the idea. Yeah.
So in fact, R PQ must be similar to ABC.
Yeah.
Okay.
Now this looks somewhat nice.
Yeah.
Yes.
So BR is O1, O2. Oh, so O1, O2 is perpendicular to BOP.
PO, right? Yeah,
PO.
Yeah,
POP.
but PO and B are collinear.
Yes.
Okay.
Oh yeah.
So.
And it's specifically the perpendicular bisector of OP.
Yeah.
Yeah. Okay, so let's look for congruent triangles.
Yeah.
Should we draw so that you essentially get O, like from start drawing from O?
No, we can just do this. Assume this is a straight line.
Yes, I can assume that. Straight line.
Oh, O1, O2 also passes through O, no? Or it doesn't? It doesn't.
No, passes through the midpoint of OP. It's the
Yeah.
perpendicular one. So.
Wait, does there exist a spiral similarity taking O1, O2 to BR?
Yeah, I mean that spiral similarity would be a rotation. And
Why do I think the center should be O of the spiral sim?
yeah, our diagram is not that accurate, so it could be true.
Yeah, someone is saying trick bash is easier.
Mm.
Okay, but no synthetic seems nice. How do you find the spiral sim center though?
Wait, actually, I think we know a lot of angles now. We know that PRQ is this. We know that PRO is PCO, which is this.
Wait, can I just draw the figure again quickly without
Yeah,
involving the circles?
Yeah, we should first draw O and then draw all the circles.
Oh, we can just skip to draw the circles, right? We know the circles. Like that way it will be nicer, I guess.
Pranav, isosceles.
Yeah,
Yeah.
isosceles.
Yeah. P and this is O. Q. Does this look better?
No.
What?
Like draw O first, then P, then Q, then R.
Yeah, you draw O, then
Okay,
B,
draw
yeah,
the
AC.
circle first, then draw the center, then add ABC.
I'm not doing ABC circle. No.
Okay, is there a circle tool?
Yeah, there is.
Like draw the circle, draw center, then delete circle.
Have an ellipse. God, how do I draw the circle? Okay. Satisfied, people?
Yeah, satisfied.
Yes.
It's all scam tactics. You know, I know. You people want to do the problem without me doing it. Not like I was contributing any much. Q should be here. Shit. Why does it pass through O? I'll just make it pass.
Because Malay already said that.
Perpendicular bisector of PQ passes through O.
Yeah,
Why?
OP is
Power of
OQ.
point.
Good point.
Power of. I mean, the power of point idea is not P1 level.
Yeah. Atul is such a scam person.
Also like OPA and OQB congruent. That was intended.
Okay, yeah. Okay, fine.
OPA and
They are
Oh.
congruent.
is this now fine, people? The diagram?
Yeah, fine.
Also, I'm getting QR is parallel to BO, if that helps.
QR is parallel to.
Sorry, QR is perpendicular to BO. My angle chasing.
Oh, so basically we're getting pure parallel to O1, O2. Oh, is
Yeah.
RBQ isosceles?
Yeah, that's a problem condition.
What?
RPQ isosceles. That
No,
was
no,
given.
RBQ, RB,
Oh.
B for ball.
Oh, B for ball.
Because,
Yeah, it's isosceles.
oh, then we're essentially done, right?
Because then RB equals BQ. Oh,
Yeah.
sorry, RB equals RQ.
And then RQ is equals to O1, O2. We have to just show because they're parallel. So just have to show the parallelogram.
Yeah. Oh, wow. So B.
So
Wow.
reduces to QO1 parallel to RO2, but this should just be angle chasing because we know a lot of angles, right?
Yeah.
Yeah.
I guess we can do this. Atul, we can do this, right?
Yes, it's equivalent. So you have to be able to do.
Yeah. So we are done, right? Or do
Yeah,
you want
let's
us to go through the angle chase?
Okay,
Yeah.
let's just do that.
Skip it if you want.
Yeah.
Just
Let's
O
just
to
skip it.
RP.
Okay, sure.
Right, sorry, O to RC is
2 RPC, 90 minus RPC, right?
90 minus RPC.
Also, another cool fact about the diagram, AP equals PQ equals QB.
AP equals P.
Yeah, I realized that.
AP equals to PQ equals to QB. Oh, yes. Wait, why do I feel like I've seen this in some problem? Atul, this might be a config, you know. Not so famous, but it might be.
If it's not famous, it's not config. The point of not making non-config is that people don't know results that kill the problem.
Okay.
Nice.
Oh, we could have got AP equals to PQ way earlier, though, right? Or no? Okay. RPC.
Oh, O is the orthocenter of PQR. That doesn't help, but yeah.
Oh, right. Yeah.
Oh, yeah.
Orthocenter.
Yeah, but still, how do you find RPC? Wait, maybe we are looking at the wrong angles. We can maybe try to show O1 Q P. Wala. Maybe this way, right?
I guess BO2O1 is not easier.
Oh, which one? B?
O2O1. Because you can compute OO2P, right? And OO2R.
To be.
Yeah.
OO2P, P, not B. P for Pranav.
समझ गया.
Yes.
O2.
And then OO2R.
Okay. Then.
So you can compute O1, O2R, and similarly QO1, O2.
How O1,
That would
O2?
give
Oh,
that.
because we have P02, O1, right?
Yeah.
Oh, so yeah. So we can get O1, O2R. And we can get O2R of Q, right? No, these are parallel.
And QO1, O2. So QO1 would be probably parallel to R02.
Yeah.
I am not doing it.
Oh, also O2, O1 is alpha, if you assume angle A to be 2 alpha. This is alpha, yeah.
Oh, wait. We can compute this angle, right? Now we want to compute QO1, O2, which is equals to 180 minus O1 QR. Oh, wait. Yeah, that is 180 minus O1 QR. That is just a parallel thing. Which is equals to O1 QP plus P. Yeah, we can compute this also. Yeah. We are done, right?
Yeah. Let's see.
This was nice.
Also, you even knew angle RPC, you've directly done.
How do we get RPC?
You know angle RPQ, you know angle APQ. Like every angle in the figure is known.
Oh, true.
Yeah.
Okay. Yeah, fine. That was a nice problem.
Yes.
Oh, wait. What was the thought process in making this? Could you like tell us that?
Like I just wanted to make something non-config and I didn't want it to be symmetric. So I thought it'll be funny if I do a non-symmetric problem with an isosceles triangle. And like P and Q were added because I just wanted to see what happens if AP equals PQ equals QB. Because it looks nice. And obviously I redefined it so it becomes harder to see. And then the initial thing was to prove that like the cool fact I realized was that circumcenter of BPQ lies on BC, which is R. But then RG was like, that's too easy.
Also,
So
I
then
think-
I did over node.
Ah,
Also, like in GGP, this is a lot easier. You just add points and just see stuff. So I
Yeah.
could directly see it was a parallel.
also like in GGB, like you can obviously notice the Mikhail point quickly too, right?
Oh, Mikhail point was actually not the idea. I just,
So our solution is different.
No, the initial way I proved R was circumcenter of PPQ, just like added the point Ananda said, AP A dash Q. Then PQ A dash R is cyclic.
Ah, yeah, because
Yeah.
PRQ is.
Yeah.
Yeah.
Ah, okay.
Uh-huh.
That's nice.
Yes.
Okay. It's not time for this problem. The statement is so long. I don't want to do it this. Ananda, can you read and explain?
N squared times the correspond. Okay. Okay, so rectangular paths and
Wait, what? In an n cross n grid, there should be 16 vertices, right?
Yeah.
N plus 1 squared vertices.
Like the cells of the
let's just
grid
assume
are the vertice, are the town.
So the
Uh-huh.
cells are the towns. Okay.
Oh, yeah.
Wait, so why does it say vertices of a grid?
vertices.
Funny.
A rectangular paths, right? So each road was traversed at least once.
Wait, so Atul, like you have this town, this town, this town, this town. This one is connected to this and this. Is it also?
No, these
connected
are
to
not the
this?
towns. The dots are the towns.
So there should be n plus 1 squared towns in that case.
Yeah.
Wait, no,
Like-
Like just take n equals 4 in that case. It's not really.
yeah, take n equals 4. The dots are the towns and
Just he's saying
lines are the
you have
roads.
n square towns arranged in a square and you have this adjacence.
Okay.
Oh, so basically, like, okay, this is the n equals to 4 config, basically, which I do, right?
Yes.
Or you can traverse this in 2 drones. Like, take one drone which goes like this, and second drone which goes like this.
No, you have to
Now read
traverse
properly.
What?
all the roads. You have to traverse all the roads, not the towns.
Oh,
Yeah, so you take 3. Oh, but you still have to cover this.
Wait, Pranav, why is the middle drone even taken?
oh, good point. To cover this, oh, which to cover.
Uh-huh.
Wait, is the answer n? No, for equals to 4, it's n. What is it for 5?
For your construction, it will be twice of ceiling and by 2.
Oh,
Yeah, for even and I think n roads like work, but no.
we have to prove that it's optimal, right?
Sure. I mean, why not?
Wait, for n equals to 5, we can do this, right? This is 1, 2, 3, 4, and maybe like this is 5 and 6. Oh, that is what Kanav said, 2 into floor by n by 2, right? Ceiling, yeah. Has anyone seen USCMO this year's problem 4? The sticks one. Oh, problem
yeah.
1.
Problem 1.
Problem 1.
Yeah, it feels similar to that only, right? In some sense.
That you have to look at.
Yeah.
These roads.
Yeah, like the thing I was thinking was, wait, how do people get the Zoom link? What? Oh, that is you. Sorry. Kanav, can you try again? I thought that was someone else. Wait, is Kanav here right now?
No, that's why he's trying to get in. So you speaking is not helping him.
Oh shit. It was not on his name, so I thought it was someone else.
I'm not sure if you can try again if you like rejected it.
Oh, he is in waiting room, it says. Yes. Okay.
P3. P3.
Hi, Kanav.
Oh my god. Okay, I'm back. Hi people.
Hi, Kanav.
Hello.
I thought it was someone else. Unfortunately. Okay.
I left on phone, so anyways. So what's better? Yeah, that's later. Yes.
Also, I think the idea I was thinking is, let's say you have a, let's call this drone as a horizontal. Okay, any drone. Suppose this drone covers like 2 things here. So what you do is like whatever depth it goes, you need a drone inside this drone, right?
Yeah.
But the issue is you can have a drone which goes even outside of this thing to cover this. So like, if we can somehow say that the number of drones remains same, if we somehow make this an inside drone and divide this into 2 drones. That's what I was trying to think. Let's target to solve this in 8 minutes. Then we'll be done in under 2 hours.
For 4 country, do it with three.
Black.
3 drones
Oh.
because you can cover the big 4x4 square with 1 drone, and
Okay.
then like one
Oh,
in
like this way and this
Yeah.
way, right? Oh,
yeah, so 3.
oh yeah, that's actually good.
Where is it?
Now it feels like induct down, like equals to 5k. Shit, man.
Uh-huh.
Like you basically, if you take the outermost square, you're left with these roads, and inside is a what is n equals to 4 case, right?
Yeah.
Equals to 3Ks.
3 case.
Or 3, yeah. We remove from 2 sides.
Oh,
So
wait, what is
we
the
have a construction for like about linear.
for?
You're trying to prove then you must cover all these roads in like one drone. Or
That is
maybe
not possible.
two drones.
Wait, what is the most optimal construction for 3? Is it 3 only?
Yeah, 3.
Yeah, for 3 it should be 3, right?
Yes. For 3, what's the construction?
Like just take this 1, 2, and 3.
Yeah. Oh.
Nice. Basically,
Also, to everyone in the chat, don't spoil it. The point of the live solve is that they try it without anyone spoiling it.
What happened?
I was asking people not to spoil anything in the chat.
Ah, okay. This way for n equals to 5, I am getting like 1, 2, 3, 4, 6 things. But I don't feel that is the most optimal because for n equals to 4, you can just do in 3. So like I'm guessing for n equals to 5, you should be able to do in less than equals to 5. Also, this feels a bit graph theoretic now. Actually, no.
Can we make the optimization that all of our rectangles have to have one side n? Because it's true in the 4 case. Is it true in, say, for the 3 case?
In 3 case, yes.
If you have a smaller rectangle, you can just extend it. That it won't be an issue.
Yeah.
Yeah.
So here, if this is sufficient, the other one should be.
Yes.
Yeah.
So each of the rectangles has at least one side n.
So we can pair up rows which have like parallel sides.
Wait, actually no, Kanav, it can be an issue. Like, what if you have a rectangle which is something like this?
Yeah, I know what you do.
Then it covers, and this is the only rectangle covering these 2 rows.
I
If
see.
you extend it, these 2 won't be covered, right?
I see. I see.
Yeah, but again, say look at that case, but then what covers the road below that road? Can you extend that again?
Oh, you mean so
Yeah.
like you had this case?
Yeah,
If you
but
extend this, you would have some road here.
yeah,
something like
what covers this thing? You extend this as well. But then, yeah.
Yeah, but then this is anyways covered,
No, but this, yeah, this is anyways covered.
and it covers more roads, right? So that is better.
No, but there might be other cases. Let's see if this is true, right?
Yeah, now it so much feels like USCMO P1, right?
Yeah, after this optimization, I think it should be easier. USMO P1 also had some local argument. Then you had to do.
Yeah. Like there were many scripts which had this thing in them. So yeah. Oh, I think the issue comes like suppose you have something like this here, and then something like this here. Oh, that is still not an issue. Or maybe something like this here. Yeah. What if you have this?
Yeah.
Then if you extend this, you cannot extend these down, right? Oh, you can.
Yeah, because drones can overlap. That's not an issue.
Yeah. And like I was wondering, this won't be covered, but then this is covered by this middle thing anyways.
So in our equality case, drones are overlapping.
Yeah, overlapping is fine. And I think everything should have an n side. Like it feels true. We are left with some details, but most of it should be.
Okay, let's see. Yeah, this is.
Wait, does this construction work for 5 drones? Or am I missing a side? Like one is the exterior triangle, one is this rectangle, one is this, and this.
5, right?
Yeah. Am I missing a side or does this work?
Yeah, this
This
is.
works.
Yeah.
This is for n is 5.
Yeah. But can we go to 4 now? Because for 4 we can go to 3.
Yeah.
Oh wait. I'm guessing if this is true, then the answer should like if for n equals 5, it's 5 only. Then for odd, it's odd. For even, it's even minus 1.
Hmm.
Let's just check for 6. Because in even case, the thing is, here you have this single row, right?
Yeah.
In odd
Yeah.
case. But in even case, everything is paired up. So that in
Yeah.
some sense reduces. Like intuition says that.
Exactly. Yeah.
Let's check for 6.
So for now, let's assume that we have proved everything must have a side of length n, every rectangle.
Yeah.
We can do the details later, but I think that should be true.
Yeah.
Then like you're essentially pairing up sides. A rectangle is doing that.
Yeah.
And like the sides which are not paired up with anything else are like covered by the short sides of the other rectangles. Uh-huh.
No, because everything is paired up. See, like in this n equals to 5 case,
Yeah.
like this big rectangle covers the horizontal sides, and the vertical sides are covered by go to the end only, and the
Yeah,
vertical
yeah.
side are covered by another big rectangle. So everything is covered by a big rectangle only.
Mhm.
Okay, this is a 6 by 6 grid. Let's see if we can do this in 5.
Okay, let's write the big square.
Yeah.
And
Yeah. And then what do we do?
right. Okay.
We have used 3.
Yeah. This works right. So
Does this? 3,
yes.
4, and yes, we can do this in 5. Yeah. 2 into n by 2 minus 1. So 6, 3, 6, 5, 5, 2, 3, 6. Yeah, this seems to be the correct answer.
Yeah.
N equal to 5, we got 5, Sunana.
Which is then.
Huh? Yeah, now this feels doable. Like after, if we show that each side should have at least n thing, we can probably show that there should be a rectangle that should cover the whole board by like probably doing the same idea.
This time I was muted, but fine.
Who is muted?
Me.
Yeah, I was seeing your reaction, but then I thought you were maybe doing it in your mind. Were you thinking that, oh God, how cruel these people are, they're ignoring me?
No, like I may be wrong. I was like, I don't know. Like you guys are focusing on the construction, I was doing the bound.
Can we count like the number of edges if that's fine? For example, there are many. Okay.
Something. This is an issue. Yeah. But wait, if you have something like this, you can merge it. Okay, I guess we can prove bound. I'm not sure. If we can prove that one side is at least 10.
one side of each rectangle, right?
Yes.
Okay.
Okay, how do we prove on?
So you can pair of rows, right?
Yes.
And so you would have ceiling of n by 2 pairs.
Yeah.
And ceiling of n by 2 columns.
Yeah.
And you can't have anything like this. So 2 rectangles can't fully cover out a column. Otherwise, you could have just merged these 2 rectangles. Follow me.
2
I'm
rectangles.
following you only.
Like this thing.
No, like the short sides of the rectangles might fully cover a column, and that
Yeah,
column.
then you can merge the 2 stones.
That's what you're saying.
No.
But what if there are more than 2?
This is an issue.
Wait, I do not understand anything.
Okay.
Like each rectangle has a long side, which is n, and a short side. So the short sides of some rectangles might entirely cover a row, and so that row does not need to be covered by the long side of any rectangle.
Yeah. Oh. That is never possible, right? Because see.
Also, like the big square has 2 long sides.
Yeah, that is fine. But so what I was saying is, like the short side, if the one side is n, the short side always goes in the end only, right? So that will never be covering any row.
No, but some. Yeah.
Like if you show that.
Yeah, that's true.
Right. So short side anyways go at the end. Also, this has n things.
Yeah, how did it see? Yeah, that's true.
Let's just try to form a thing without using the n cross n, like with 1 cross 1 only. Like we are anyways using the pairing arguments, no? So let's see. This is 1, 2, 3. Four, 5. Okay, I think we have to use an n cross n.
6. Okay.
Yeah.
So
But
6.
n cross
We
n
can
makes
do it
sense.
with 5 because the big square has 2 pairs of long sides.
Yeah. So it covers everything in the boundaries. So
Yeah.
you only are left with the other.
Yeah, I think that should. Okay, we still haven't proved, I think, completely regular.
Yeah, that there should be an n side in each rectangle. But let's just assume that for now. And let's find the bound. Oh, by the way, Atul or Rushil, we're not checking the chat, so if there's any important message, you can just tell us so that we don't get stuck.
Yes. You are fancy people. That's what the chat says.
$20 of watch time. 2 hours, so at least 10 people are watching.
It says 236 views. Average view is 5 minutes, 15 seconds.
This is not an issue. This is. Goodness. Yes. What is it doing?
If there is this kind of overlap, we can just do this rather, right? Like take one as here and the other as here. Oh, no, not here.
No, this middle part. No. Like this line wouldn't be counted again, so you can't merge.
No, you can do this. Like take blue one to be here and orange one to be here. So blue one
Right.
becomes this and orange becomes this.
Right.
Yeah.
But then the issue is this gets rejected. This is not counted, right?
Yeah, but you can still stretch out the blue until here.
Matlab?
Like,
Okay, we can do casework on whether the big square is there or not.
do this here, move this.
If the big square is there, then
This. No. Wait, no, nothing. Still is required. Color. Still missing out.
This is like the hardest problem on the test.
Way too good.
What?
Okay, I will say like I think 20 minutes ago you had the solution already, but then you erased.
Not 20, more than that actually.
What?
Like, okay, I don't think they meant to do it, right? But
You accidentally wrote the solution on the Misho board.
Wow.
That is so funny.
I mean, like, I can show you a screenshot later on of that being written down like ages back.
What did we
but
write?
we didn't have any ideas for the bound, right? Like,
I think you were like drawing the board and then like you
Yeah.
were halfway through and you had the solution.
And 20 minutes ago. It's like before.
Okay,
that.
leave it. Just
Kanav,
do
you
it.
were doing the bound
Like,
20 minutes ago, right? So
Wait, so Kanav wrote that thing?
you're not going to get anywhere from this. Like from thinking about what happened 20 minutes back.
Time to live in past as always.
Yeah.
no, that was not 20 minutes ago, because when Pranav said he did the bound, Atul sent his message, which was 9:08, and this is 9:17. So 8:15.
20 or like 45 minutes ago almost. I don't know.
Mhm.
So that was much better.
21 minutes and 40 seconds.
Can I just look back in the stream?
No, okay, done.
It's not. That's not.
You won't realize it even if you see it. So
Sure,
just
I'll see it
continue.
then. I'll just see it.
No.
Okay, no.
Okay,
No,
fine.
don't.
I'll take an idea. Like for it.
Good boy.
Okay, now I think there's an issue with assuming every rectangle has a long side. Because you can't just, if you extend that and you extend the rectangle below that, then that also leads to some problems. And maybe you shouldn't have a season, but that is true.
No, I think not.
Mm,
Because like suppose you have something here and you have something here. And let's say you have something here. So if you extend this, this becomes this. And now we are not able to cover this and
because
this.
you're
right?
assuming that all of them have width 1, because the issue is when this rectangle has width 2 or bigger.
Sure. You mean like this one?
Yeah. And now you try to extend it in one direction, say. And say that what do you say? The contents of the roads inside this 2 into 2 square are covered by the rectangle below it. Then you can't extend because then you're losing that road.
Right.
Okay, maybe I should draw. I can draw this.
Where is my turn?
Where are we?
Oh, click on someone's PFP.
Okay, got you. This is pen. So suppose you have something like this.
You cannot see where. Okay.
I'm drawing in red. Okay, I can see it on my screen.
Yeah, I can also see. I can see.
And then you have something like, say, this. Now, if you try to extend this way, then you'll also have to extend this way to cover up for, wait, sorry. That's not what I meant. Let's say you want to extend this side this way.
So reduce thickness, bro.
This side you want to extend this way. Then you're losing this road. So you'll have to extend this upwards. But then you're losing this road.
No, but you would have something right here too. Wait, no. Wait. You would have something right here going like this. Okay, not necessarily there, but something, maybe something like this. No, wait. Like from right. No, from every row you must have something starting. Wait, no.
Oh, maybe you have something above it. Then you can extend that downwards.
You must have something originating from this row. Which pair? Oh, wait, no. I guess I was doing that 20 minutes ago or no? Yes,
Okay, leave that.
No, it's right. I was doing something like pairing, but with the column n. Right. So.
Oh, yes.
Yes. You have that there exists a rectangle starting at every row, which pairs of some other row.
Yeah.
So you can pair of rectangle. Like that row must give a unique rectangle.
Every row must.
I don't know what I'm saying, but. Right. So from a particular row,
yeah,
you have some rectangle starting from it, maybe more.
Oh, so the bottom part of that rectangle is, yeah, okay, I get you.
That must be different, right? Like this pairs off with some other rectangle where it ends, starting from the bottom part. And this must be unique for every row which is not paired off yet.
Yeah, because if it's not unique, then you're not getting much, right?
Yeah, so then I guess we are done. So you can pair of rows.
Yeah, and you can pair of columns.
Columns are issues. Columns are issues. Again, same thing.
Right.
Like, why should starting from here give a different thing, right? This may be same.
No, like once you have paired up the rows, now each rectangle, like there should be a rectangle starting from here also, which you pair it from here, right? And now let's say you take a rectangle starting from here and you pair it with this again, then that does not give you much, right? Instead, you can pair it to here. That's what I'm saying.
I don't get it.
Like the same idea for rows, no?
Like what I was doing. So, but what if you start at this column? No. What column are you pairing this with? The rectangle that starts here ends at say this row. So this is an issue.
Wait, how are you doing rows again? Can you tell me? I think I
You
missed
take the
some
bottom
message.
one.
Yeah, I take
It's
this
just a
point.
rectangle starting from the above edge. This edge.
Okay.
This pairs off with some other rectangle.
Yeah, like where this goes till until, right?
So that row is paired off with some other row.
Yeah.
So you can pair off rows, but you can't do the same thing with columns, which is sad.
So here, aren't you pairing columns? Like vertical things you're pairing, right?
Yeah, so then once the एक बार rows कर लिया, then do columns. But that is not
अब
possible.
हम इधर आए. Wait, I feel the same argument would work. No, I don't see the issue.
Like what if you have
wait.
something like this square?
Wait, let me draw.
Yeah, this is going to, I'll just delete my stupid sketches.
No, I'll just create something on that. Yeah, Kanav, can you tell her?
1 second. Yes. Yeah, so okay, I'm doing for rows.
Wait, row is this, right? Like the horizontal.
अच्छा हाँ मुझे row column confused हो गया. Right, I don't have brain. Yes, rows are these. Sorry. So start with any row. There exists a rectangle starting from this edge.
Yeah.
Pairs off with some other guy.
Sure.
So you can pair of these rows.
Yeah.
Give some rectangle, unique.
Yeah.
I was trying to do the
Okay.
same thing. So you have like
issue here is, wait, like why can't you do this?
अरे यहाँ से start होगा यहाँ पे end होगा तब करूँगा ना.
Yeah, like you're pairing, right? So I have paired this with this. But now, why can't I pair 2 and 4 also? What's the issue?
You can.
But you can also extend this beyond without affecting anything.
No, like what if, let's say the above thing ends here, okay? It's like this. And then the second thing you have is, like second one goes up to like 6 things, all the things. And then this. Now, if you extend this, like this, sure, you're not losing anything here. But you're losing things here, right? That's what I'm saying. Does it make sense?
Yeah.
Right. Okay. So when you were doing this column, this is column, no? This is column.
Mhm.
So rather than focus, there are two things. You can focus on this edge too. That is, there will be some other rectangle going in this direction.
Mhm.
So that would pair off this column with something else. This column is something else, giving some rectangle. Something like this, I don't know what. But this rectangle would not be counted before.
What do you mean by before?
Before मतलब पहले rows कर दिया. Rows would give all distinct ceiling n by 2 rectangles. And
Yeah,
columns would
at least ceiling n by 2 rectangles.
Yes, at least ceiling n by 2 rectangles. And columns, either this direction works or this direction must work. Just because this rectangle must start from the first row, or like this works for any argument, I guess. But it was already paired with something else. Like, how do I explain it?
Oh, I see the point. Like, okay, I see the point for rows that how at least n by 2 you have. For
But like
column,
columns, we do the exact same thing. You just pair of columns for distinct rectangles.
yeah, so what's the issue?
But the issue is, again, I'll just delete all this stuff. What if you have this black rectangle? This one. So when you started at this columns get paired off with this thing, but they count for the same rectangle.
Okay.
So this is what I'm trying to avoid.
Also, like this thing which is covering that purple edge might come into this black square.
This purple edge.
The purple edge, right? Oh,
But
sorry.
can you mark that? Purple edge? Also, Ananda, advice, reduce pen thickness.
Yeah, so by pen thickness, how do I reduce it?
Oh, like when you change the color?
Yeah. Got it. So like the square might come in like this.
Yeah. But it is different from this rectangle. No, that's all I care.
Okay.
Yeah, so we can just start from the second column, and any rectangle we get is different from that. And like,
I need n by 2 हर column के साथ करना.
No. The thing is, see, if you're starting from the first column, right? If we go up till there, no, the point is if we start from the second column, like we can actually start from second. We can ignore the first one because, like, if we everything is covered which is starting from the edges in the first column. Like, see, I want a nice color. Yeah, like all these things are covered because of pairing up, and since everything should have length 1, these things are also covered, right? After pairing up. So we can just start from the second column. That will still be optimal. So we'll have like at least n by 2 plus n minus 1 by 2. And this should be nice only, right? Like it's not that off. It's not that off than 2n by 2. It's only a difference of half. We can probably
but this is the answer we got, right? N
this is exactly the answer.
N minus 1 by 2.
This is exactly the answer. Yeah, this is same. These are same.
Yeah,
so we are done.
Are we?
Could you repeat the solution?
Okay. So you start from any row first. And then you have some rectangle covering this edge. This will be paired off with some other row.
Yes.
So you can pair off n by 2 rows and these all rectangles would be different.
Yes.
So you're ceiling n by 2 distinct rectangles in the rows.
At least.
Yes, at least.
Yes, but also there's the entire border rectangle possible.
Yeah. If that maybe, then you pair the first and last row.
Okay. But
And
the
then
bottom
we
one will
start-
contribute to both column pairing and row pairing.
So we start column pairing from second.
Okay.
Wait, no, right and down.
Why? What's the issue?
Last column.
Mm.
Maybe we can take two cases, like when it goes till the last column and when it not.
No, wait.
Oh no.
Do it from first only and then subtract one. Because, yes.
Okay, so the issue now is, let me paste this. Like if we have something of this like big thing, right? Then how do we pair up the columns? This is the issue, right? Kanav?
Yes.
Also, sorry, this is not the answer actually, because this is always n. And for even n, we found a construction for n minus 1.
No,
Both of these are ceilings, right?
yes.
Yeah.
Yeah, so this is always n.
This is not equal to this. Yeah, an answer of this, right?
This n minus 2 work there. Like ceiling of n by 2 plus ceiling of n minus 2 by 2. Yeah, that works because you can write it, you can take the n by the second term is ceiling of n by 2 minus 1 and you can take the minus 1 out.
Yeah, so
Yeah, here you want 2. Here you wanted 2.
When you read the last column. When you read the last column. Okay, wait. I may be wrong. But you do the same things for rows. You get ceiling n by 2 stuff. Then you start doing the same thing for columns. So the first row is an issue, I guess. Not again. And then
Yeah, just a second. I was just going to try to start screen sharing. My screen is visible now, right? Oh, my screen is visible, right?
Yeah.
the way you're looking at this can be thought of better.
Oh, what is the issue when we pair with the last column here? Like, what was the issue when we pair, like, let's say this and this, है ना?
Huh?
Like, अगर हमने इसको और इसको pair कर दिया इस बड़े rectangle केस में, तो क्या दिक्कत है?
This is not an issue because they started from here.
Sure, start from here. What's the issue then?
No. You pair first thing with anything else is an issue.
You're not considering the first rectangle anyways, right? Like first column.
Exactly. Wait.
I just
But
said
then that is not an issue if you pair anything else with the first thing. Right. So
like we can just not consider first column because anything which is connected to this, yeah.
but then when you're pairing other columns, they may not have any choice except the first thing.
That is fine. Just pair it with anything. Like, so you mean the case when they are like here there are odd columns, right? Odd number of columns. So we have paired, let's say, these two and these two. This does not have any choice, right?
Yeah.
Right.
Like, I mean, for example, you start from this guy. The only rectangle containing this edge is this.
Yeah.
Then this is an issue.
No, instead of
But if you can prove that we have at most one rectangle which have an issue, then we are done.
also wait. When we are pairing, is this not an issue? Like, let's say the pairing gives you something like this. Suppose okay, this is paired like this. This is paired this way, and this is just paired like this. And now in columns pairing, these are paired like this, and instead of this, it just goes up till here. And these things are never covered.
That is, I'm taking an optimal thing and then pairing, no?
Oh.
Like optimal thing pairs of stuff.
Oh yeah, what Pratul said is right.
Oh, I'm not checking
Check
that.
chat.
Not easy.
Because number of pairings in odd and even is same, right?
Check Zoom chat frequently.
Oh, so the issue is like, then you have 2n/2, but you want 2n/2 minus 1 somehow, right?
Yeah, so here we had n-1, but we want n-2. That is
Yeah.
ceiling of n-2/2, which is ceiling of n/2 minus 1.
Uh-huh.
Is the n/2 coming because the borders would be covered?
What do you mean?
like here you want n by 2 plus ceiling of n by 2 plus ceiling of n minus 2 by 2. Here this n minus 2 is coming because like the borders are covered. Is that the thing?
Yeah, we're trying to remove borders.
I think it's some common theme. Everyone of us knows that. Yeah.
So. Right. Okay. Hi people, I'm back.
Hi, Beth.
So we will do the except for the endpoints. If stuff are paired off, good. If something is not paired off and it caused an issue, it must be paired off with the first column. Right?
No, I don't understand what you mean.
Okay.
Yeah.
So first pair of rows. Fine. So first column is paired off, say, with this row. First row is paired with this row. Third row.
Yeah.
Okay. And then we do the exact same thing with columns except for the endpoints.
Except for the endpoints.
Yes.
Okay.
You can pair of columns. So if you will have distinct rectangles, except when a particular column is paired with the first row. That is, there is nothing else.
First or the nth, right? Like, let's say you have nothing to pair this.
Yeah.
So it can be either paired with this or this.
No. Nth is not an issue. No, because we are trying to pair with this edge. We've fixed it directly. Okay, so how we are pairing columns is for any column, choose this edge. This edge must have a rectangle. It pairs off with some other row.
That is row pairing, right?
Yes, that is row pairing. That's the first thing that we do. This gives all distinct rectangles.
All distinct rectangles. No?
Like all the distinct, like all of these pairings give distinct rectangles.
Yes.
So we get at least ceiling n by 2 rectangles.
Yeah.
Okay, so far you have, okay, just to get it there. So far you have paired the rows and you have ceiling n by 2 rectangles. Okay.
Yes.
But I didn't get that what you're doing with the columns that delete the endpoints and.
Yes, except the endpoints, we start by pairing columns. If a column is non-endpoint column is paired with a non-endpoint column, that would give a distinct rectangle counted before.
Yeah.
And so if a column if a column is paired with the endpoint.
Yeah.
So if it's paired like this column is paired with the right endpoint or this endpoint, there wouldn't be any issue. This is also a distinct rectangle. right?
Yeah.
So the issue comes when a particular column is paired with the left endpoint.
Yeah.
For example, like this thing.
Yeah.
And when the like other edge is the third column, which was the pair of 1.
Yeah.
And then only then we'll get an issue.
Yeah.
And wait, okay.
Oh yeah, we are done, right?
No. Oh my god, I thought.
Okay, so the only issue now left is,
Okay, yes, we are done. Yeah.
yeah, like no, we are left with this thing and this thing, right?
Yeah,
When we
but
have
So,
the row counted only this one.
yeah, so we are done anyway. So
Yes,
we can
yeah.
have only one issue triangle. So it's like 2n by 2 minus 1, and we have a construction for that.
Is this correct, Atul?
Yes, essentially. Like, you can think of this in a much better way. Like,
In a way that was put 37 minutes back. Or
oh no,
something.
that's an improvement. That was my solution. This is someone else's solution here. Central team. It's like between first column and second column, draw all edges except top one. Erase the weird stuff.
Wait.
And then same between first row and second row except the first edge. Every rectangle covers at most 2 of these.
Why at most 2?
Like by construction. Draw those edges.
Like these edges, right?
Yes, and the same thing reflected over there.
Yeah, that's what I did.
So you need at least n minus 1. And in case of odd, the left top corner won't be touched if you use exactly n minus 1. So you need n in that case.
Oh. Wait, I still don't get the proof.
Wait 1 second. No, Atul, for odd, you can still have like let's say take the first entire column as your first rectangle. Like a 1 by n.
All right. Okay, but you can eliminate such
Yeah,
cases.
that's why I was stuck on this case. I think your thing is just better for that, where you take all 4 and then.
Yeah, so essentially in most solutions, you get either at least n minus 2 or n minus 1. And you just analyze equality case and improve the relevant points.
Yeah.
Like, I feel like you were thinking too much in terms of pairing the rows. And like, if you didn't get a pair, you were kind of ignoring those initially, but it just counts as 1 and you wasted a rectangle essentially, in a sense.
Okay, all the problems are nice though in general.
Yeah.
Except P1 probably.
What
So
is
P1
not
is also
nice
nice.
in P1?
Wait, P1 is probably my favorite in contest.
Yeah.
P2 is slightly scam.
Yeah.
P2 was
4
decent. P2
combos.
was
Oh yeah, this was too much combo, right?
what was combo
Are you
in
counting
this?
P2 as
Yeah, 1,
combo?
2, 3, 5 combo.
Yeah.
I mean, okay, 1 fine. Like 1 also the idea was at the end of the day like creating a 2n plus 1 polygon, basically
I
geometry.
haven't even done.
Don't worry, Kanav will spoil you nicely. Okay, we solved
Okay,
them
only
in
3 and 5 were combo, right?
no. Okay, in some sense, yeah, because 2 is more like NT.
No, but
2
it is combo.
2 is just NT.
Like okay, it's a modern combo, which is essentially NT.
Yes, it's
No,
ISL.
there was this.
It's
You mean
ISL.
modern NT, which is essentially combo.
Yes.
Oh yes,
Yeah.
I said
Yeah.
N4. Here's N4. It's ISL N2.
yeah. Also, we did all the problems in like 2 hours 55 minutes. Okay, not bad
Yeah,
for a 9-hour contest.
Also, I
Uh-huh.
checked, apparently P3 Sybil in drones is flavor text from some anime called Psychopaths.
Okay, my question, I wanted to ask this question. Why Sybil and drones? It's creative, but still, why Sybil? I don't even know what Sybil is.
Yeah, like apparently it's from an anime called Psychopaths. And Sybil is some sort of system which has automated rules. I don't know.
Kanav is like, okay, but do I look like I care?
No. I just don't care about. Oh wait, chat.
By the way, I was saying Kanav, not Pranav.
Yeah, end stream.
Wait, we got like. Let me count the watch time. Probably off
Just
screen.
end the stream first.
Pranav, end stream.
Yeah, I forgot. How do I end stream? Let me find the button. Wait, let me find the button to end stream.
Bro.
Uh,
Stop sharing and then find it. It'll be easy.
Yes.
okay, I found it.